But Baalbek, if there was one example, one ancient site on Earth that is evidence of a lost, ancient, advanced civilization, and by advanced, I'm not talking about space lasers here. I'm talking about...
Baalbek is celebrated as a triumph of Roman engineering. But what if that belief is wrong? Imagine stones so enormous and construction methods so advanced that modern history struggles to explain them. What if these mysteries point to lost or civilizations far older than we're taught? This isn't just an archaeological curiosity. It's a serious challenge to our understanding of ancient human capability. In this video, I explore the startling discoveries that have pushed experts to rethink Baalbek, uncovering secrets hidden beneath the site for thousands of years. The enigmatic foundation stones. Baalbek's reputation has long rested on its enormous stone blocks, some of the largest ever quarried by humans. These foundation stones weigh hundreds of tons each, dwarfing anything found at comparable ancient sites. For centuries, the prevailing belief was that the Romans had constructed the entire complex, using well-known engineering techniques to move and position these massive blocks. That view, however, has become increasingly difficult to maintain. New research reveals details that do not square with Roman technology or methods. The real puzzle lies in the origin and placement of these stones. How were they quarried? Why were such colossal stones chosen over smaller, more manageable blocks? And what tools did the builders use to shape them? Traditional answers seem insufficient, as the evidence points toward methods and materials unfamiliar to historians. Researchers working at Baalbek have found contradictions in everything from tool marks to architectural style. Many assumptions about the site have come under scrutiny. For years, any inconsistencies were dismissed as measurement errors or misinterpretations. But as new technology allows deeper analysis, these discrepancies demand fresh attention. The stones do not fit the Roman mold in either construction style or engineering principles. It is as though the foundation itself belongs to a civilization older and more advanced than previously imagined. Beyond just the sheer size of the stones, their arrangement raises questions. The trilithon, a set of 3 colossal blocks, is a feat unmatched in its complexity and precision. Each block weighs around 800 tons, and one even exceeds 1,000 tons. The logistics and planning required to shape and position these blocks suggest an operation beyond the reach of known ancient labor or technology. Yet, the archaeological community remains divided over how to interpret these facts. The foundational platform itself seems to resist categorization. Its engineering does not align with typical Roman proportional systems or architectural signatures. This mismatch forced scientists to ask a fundamental question. If the Romans did not build these stones, then who did? The answer to this question holds the key to rewriting Baalbek's history, and perhaps much more about ancient human civilization. One point of intrigue is the site's location. Researchers cannot explain why Baalbek was chosen for such a monumental project. Some suggest it could have been a power place, a site with special cultural or spiritual significance. Still, even this theory cannot account for the extraordinary engineering skills required to build what we see there today. The deeper the investigation goes, the more baffling the picture becomes. Adding to the mystery, Roman records make no mention of such a massive construction undertaking. No official documents describe the quarrying or transportation of these giant stones. It is as though the foundational phase of Baalbek's construction fell outside their historical narrative. This silence nudges researchers toward alternative explanations that challenge conventional history. The stonework's longevity also adds to the enigma. These massive blocks have remained intact and stable for thousands of years, despite natural forces and seismic events. Their placement on the bedrock shows an unparalleled understanding of geology and engineering. The builders accounted for minute differences in rock strength and subsurface fractures, ensuring the site's enduring stability. As we consider these anomalies, it becomes clear that Baalbek is not just an impressive ancient construction. It is a signpost to an incomplete story. This story involves forgotten technologies, lost skills, and perhaps an advanced civilization that predates the Romans by millennia. And with that, the stage is set to explore the evidence hidden in the stones themselves. The mystery of who built Baalbek. We must now examine what the stones reveal beneath their surfaces, starting with the tool marks left behind, which refused to fit any familiar ancient method. Unusual tool marks revealed. The surfaces of Baalbek's monumental stones carry microscopic clues far beyond ordinary inspection. When examined closely, the tool marks on these blocks show characteristics unlike those made by Bronze Age or Iron Age chisels. Historians and archaeologists expected to find signs of traditional hand tools, but the reality was quite different. The markings consistently defy comparison with known ancient techniques. Initial scans revealed channels with remarkably uniform widths and smooth surfaces. The cuts ran deep and straight, lacking the irregularities or hammer pitting typical of manual chiseling. This level of precision suggests the use of tools or methods not documented in any ancient Levantine or Roman context. Even traditional wedge and pick designs from Phoenician or Assyrian origins failed to match these patterns. The team expanded their search across numerous tool styles in the AI's extensive database. Roman iron chisels, Neolithic flint tools, and other cultural methods yielded no match. This absence threw into sharp relief the possibility that Baalbek's stones were shaped by a completely different process. The discovery challenged long-held assumptions about the technology available at the time. Adding to the mystery, chemical analysis uncovered traces of non-local abrasive minerals such as quartz sand and corundum embedded along the cut surfaces. These materials are significantly harder than limestone and capable of grinding stone when mixed with flowing water. Their presence suggests an intentional use of water-assisted cutting techniques far different from hammer and chisel. This abrasive water cutting is a method seen in modern industrial contexts rather than ancient ones. Its application at Baalbek implies knowledge of controlled scientific processes designed to shape the stones with a precision that was previously unimaginable. According to some researchers, this points toward an organized and deliberate engineering approach instead of trial-and-error craftsmanship. Another breakthrough came from studying the quarry floor. Patterned fractures and vertical cracks aligned with freeze and thaw extraction methods. This technique involves carving trenches around a stone block, filling them with water, and allowing winter's freeze to separate the rock naturally. Such a method was found in distant prehistoric sites, but never at the monumental scale of Baalbek. The combination of water-assisted cutting and freeze extraction indicates a highly specialized system not recorded in Roman or earlier Levantine traditions. The builders clearly pursued a controlled, efficient approach, employing environmental and material science knowledge far ahead of their time. The evidence opens the door to reconsidering who possessed such advanced skills in the ancient world. Despite these findings, the tool marks and quarry evidence deepen the mystery rather than resolve it. They reveal a lost engineering system, one that contradicts the prevailing narrative of Baalbek as purely a Roman creation. The stones themselves whisper secrets of craftsmanship unmatched for thousands of years and point toward an unexpected origin. Yet, uncovering how these stones were cut is only one part of the enigma. Moving such colossal blocks presents an even greater challenge, one that forced researchers to rethink ancient capabilities entirely. Advanced quarrying techniques. The quarrying processes at Baalbek betray a level of sophistication rarely attributed to ancient civilizations. The freeze and thaw extraction method suggested by fracture patterns implies a nuanced understanding of natural forces and material behavior. Workers would have carefully carved trenches around massive blocks, then flooded these trenches so that winter ice could widen the cracks and separate the stones with minimal effort. This approach is efficient but requires precise timing and environmental knowledge. Such a technique is documented in far northern regions with harsh winters, like prehistoric Scandinavian and some early Chinese quarries. For Baalbek, located in the Levant, this raises unexpected questions about the builder's expertise and environment. Employing this method in a milder climate would demand meticulous planning, possibly even artificially controlled water flow and temperature management. Complementing this extraction method, the evidence of water-assisted cutting marks is equally remarkable. Using flowing water combined with imported abrasive minerals, the builders achieved precise cuts with minimal damage to the stones. This method signals a move away from brute manual labor and toward a scientific process often linked to far later industrial applications. These advanced quarrying techniques also suggest a highly organized workforce with the capability to manage resources like quartz sand and corundum, which did not naturally occur in the area. The importation of these materials indicates logistical planning and specialized knowledge, reinforcing the idea of an engineered system rather than primitive experimentation. The quarry evidence also reveals engineered channels on the floor designed to control water movement. These shallow canals guided water flow strategically around the rocks to optimize the freeze and thaw process. Such infrastructure points to a level of civil engineering that is inconsistent with traditional theories for the region and period. These observations place Baalbek's construction well beyond the realm of simple ancient stonemasonry. The builders combined natural phenomena with innovative technology to extract and shape stones at an unprecedented scale. This challenges the accepted view of prehistoric Levant societies and their technical capabilities. Still, quarrying the stones was only part of the challenge. Transporting blocks that weigh as much as several modern trucks presents problems that defy conventional solutions. This ongoing puzzle pushes the limits of what we believe ancient people could achieve. With these advanced cutting and extraction methods uncovered, the question of how these stones moved from quarry to construction site intensifies, revealing a logistical enigma that remains unresolved: the transporting impossibility. The process of quarrying Baalbek's massive stones was itself astonishing, but moving these giants posed an even greater challenge, one that has baffled experts for decades. To understand the logistics, the research team fed every known variable into a powerful AI system. It took into account factors like the exact weight of each block, the strength limits of wooden rollers, tensile capacities of ancient ropes, terrain slope, soil friction, and even weather conditions reconstructed from historical climate data. Their goal was to test whether any traditional transport method could have succeeded under ideal circumstances. After running over 10,000 simulations, the results were sobering. Wooden rollers, a commonly assumed method, failed almost instantly under the enormous weights. Some blocks tipped the scales at 800 tons or more. The pressure would splinter and flatten the rollers, generating enough heat to char the wood in repeated attempts. Even with a continuous replacement of rollers, the stones could move only fractions of an inch before the system collapsed. It was clear that the famous rolling technique could not explain Baalbek's stone transport. Rope hauling fared no better in the simulations. To pull even a single large block, ropes would have to be wider than a human torso to meet the tensile strength requirements. The sheer mass of rope needed would outweigh the workers pulling it, making the system inherently impractical. Known ancient rope-making traditions simply did not produce fibers strong enough for this scale of labor. The AI classified this method as an impossibility, given the materials and knowledge available at the time. The workforce numbers were equally staggering. The AI calculated that moving a single stone might require over 30,000 people pushing or pulling simultaneously. Not only does the site lack the physical space to accommodate so many laborers around one block, but coordinating such a crowd would also have been unmanageable. The notion of brute human force alone as a solution fell apart under scrutiny and was labeled unrealistic by the team. Sledge transports, another common theory, also failed simulation tests. The stones sank deeply into the soil in most scenarios, and attempts to mitigate suction by wetting the ground only made conditions worse. The challenge of ground deformation added another layer to the problem. No traditional sledging approach could consistently overcome these issues while handling stones of this magnitude on rough terrain. Faced with these dead ends, the AI proposed a more intricate model. It suggested the builders engineered longer but smoother routes, reshaped the terrain to support heavy loads, and employed triple-layer roller systems alongside weight distribution platforms designed to reduce pressure points. Achieving such precision would demand extensive surveying and advanced civil engineering knowledge, none of which is attributed to any known culture in the ancient Levant. The researchers now understood that transporting Baalbek's stones was not a demonstration of brute strength, but of extraordinary design and planning. This insight forced a paradigm shift, as the site's builders clearly possessed engineering skills that far outstripped historical expectations. The burden of moving these megaliths might have driven technological innovations lost to history. The transport problem opened a new avenue for exploration, redirecting attention from earthly engineering feats to what lay beyond, the sky itself. The alignment of the platform hinted that the mystery might extend past geology and machinery. As the logistics of moving massive stones reached an impasse, the investigation naturally turned toward a question that pierced the horizon. What ancient knowledge did the builders hold about the heavens that guided their construction? Astronomical alignments beyond Rome. The architectural puzzles of Baalbek led researchers to analyze the site's orientation with astonishing results. Using laser measurements, precise sightlines, horizon profiles, and solar data, the AI cross-referenced this information with sky models spanning 12,000 years. It checked alignments to solstice sunrises and sunsets, equinoxes, planetary risings, and accounted for the slow axial precession that changes star positions gradually over millennia. This comprehensive approach aimed to uncover the temporal context embedded in Baalbek's design. The findings stunned the entire research team. The main platform's alignment pointed to the summer solstice sunrise, but crucially, not for the Roman period as previously assumed. Instead, the best geometric fit corresponded to a date between 7,000 and 9,000 years before the Common Era, a prehistoric era far preceding written history. This estimate is preliminary and requires further validation, but the precision was enough to exclude mere coincidence. Such an ancient solar orientation suggests that whoever built the foundation had deep astronomical knowledge, capable of predicting sunrise positions centuries in advance. This challenges the long-held notion that early Bronze Age or late Neolithic cultures in the Levant lacked the sophistication to engage in such careful celestial planning. Baalbek's builders clearly understood solar geometry and horizon modeling at levels not attributed to them before. Comparisons with other ancient megalithic sites revealed striking parallels. Places like Göbekli Tepe in Anatolia, Nabta Playa in the Egyptian desert, and the Maltese temples all display architectural features aligned with significant solar and horizon events. These correlations imply a widespread prehistoric tradition of sky observation and monument construction to mark celestial cycles. Baalbek appears to be part of this deep ancestral pattern. The revelation unsettled the team profoundly. Some scientists called for independent verification of laser measurements and sky models, while others engaged in heated debate over its implications. If Baalbek's foundational platform indeed belongs to a prehistoric horizon program, then its construction predates the Romans by thousands of years, fundamentally rewriting its historical narrative. This shift in focus, from terrestrial engineering to celestial alignment, prompted a fresh survey of the ground beneath Baalbek. If the builders oriented their work by ancient skies, then the placement of stones might also reflect an intricate knowledge of geology and soil mechanics. The investigation was far from over, and the layers of Baalbek's mystery deepened. The implications stretched beyond archaeology into the realm of ancient science and cultural continuity. Baalbek was no mere Roman monument. It was a celestial map carved in stone by people whose knowledge surpassed everything once believed possible. The site's alignment to a prehistoric sky not only broadened the scale of inquiry, but hinted that ancient builders were guided as much by the heavens as by earthly foundations. Their legacy, encoded in stone, challenges us to see ancient history in a new light. If the sky was their guide, then every stone, every cut, and every placement tells a story of a civilization whose achievements we are only beginning to understand. Geological mastery underfoot. Beneath the grandeur of Baalbek's colossal stones lies an equally impressive feature often overlooked: the masterful selection and preparation of the bedrock beneath each block. Using ground-penetrating radar and detailed soil tests, researchers mapped the subsurface in 3 dimensions, uncovering a sophisticated geological strategy that defies expectations for an ancient site. What emerged was a precise pattern. Every massive stone sat on the strongest, most stable patch of bedrock available, with only a few feet difference separating success from potential structural failure. This deliberate placement suggests that the builders possessed an advanced understanding of soil mechanics and geology. Avoiding weak zones, fractures, and fault lines with such accuracy requires surveying techniques and geological knowledge typically associated with modern civil engineering, not early historic or prehistoric societies. The level of precision applied, down to the inch, implies organized teams of specialists coordinating construction with scientific awareness. Laser scans of stone joints revealed another layer of engineering brilliance. The stones were not simply fitted side by side. They were cut with intricate shapes that self-tightened under the immense weight pressing down. These dynamic joints distribute stress in ways that reduce the risk of damage during ground movement or seismic activity. This is comparable to modern earthquake-resistant design techniques, uncommon even in later traditional construction methods. While historical builders often relied on shear mass or arches to handle heavy loads, Baalbek's stones employ a more nuanced approach that adapts dynamically to shifting forces. Similar dynamic joints are known in much later structures, such as Japanese pagodas, but are entirely absent from Roman or Egyptian architectural practices. The combination of geological mastery beneath and mechanical sophistication above sets Baalbek apart from known ancient traditions. These findings force us to reconsider the assumed technological capabilities of ancient societies in the Levant. Rather than primitive or rudimentary builders, Baalbek's creators acted as seasoned engineers, blending geology, materials science, and architecture into one cohesive system united by intent. This challenges conventional timelines and cultural attributions. Some experts caution that these conclusions require more on-site sampling and independent verification, but the evidence so far presents a clear pattern of deliberate and exceptionally skilled site preparation. The evidence is unsettling in that it points toward lost knowledge and sophisticated organization long before what history records. The stones rest not only on bedrock, but on a foundation of advanced thought. The careful geological surveying further deepens the mystery of Baalbek's origins. Was this knowledge developed locally or inherited from an earlier civilization? And if so, why was it lost? The questions weigh as heavily as the stones themselves. Yet, the precision in earthworks and structure cannot be ignored. This meticulous placement also suggests that sizing and shaping each stone was no accident, but part of an integrated plan involving detailed measurements, engineering foresight, and long-term structural stability. The builders designed the entire system to function as a dynamic whole, far exceeding mere monumental display. As the scale and sophistication of the infrastructure beneath the stones become clear, the next challenge is to confront the incomprehensible size and weight of the stones themselves, amounting to an engineering feat that continues to defy explanation. The immense scale of the stones. The enormous size of Baalbek's stones is staggering even to modern eyes. Individual blocks like those in the trilithon measure approximately 64 feet long, 14 feet high, and 12 feet thick, each weighing close to 800 tons. This is not symbolic exaggeration. These figures represent tangible, graspable masses that challenge the limits of human construction throughout history. Handling such immense weights is difficult to fathom, given the technological constraints assumed for ancient times. Yet, even these monumental stones pale in comparison to certain quarry finds. One block, known as the Stone of the Pregnant Woman, weighs in at roughly 1,000 tons. It was shaped almost fully in its quarry, yet left untransported, a silent testament to the limits of moving capability. More shocking still is a block recorded in a 2014 survey estimated at around 1,650 tons, a colossal weight surpassing any other known prehistoric megalith. These weights exceed the expectations of ancient engineering on multiple fronts. Modern analysis incorporating physics, material strength, and workforce constraints conclude that no known technology from early history could have managed the lifting, hauling, or placement of such stones. Even the basic infrastructure required to support their movement, roads and lifting rigs, would represent massive projects on their own. The AI modeling confirmed this stark reality. It found no feasible crane systems available to early societies that could safely manage these loads. Roads would need unprecedented engineering to support transportation. Ropes of the necessary tensile strength did not exist in ancient materials. The manpower calculated to move the stones reached logistical absurdities, requiring tens of thousands of workers acting in perfect coordination and space-intensive arrangements that the site cannot accommodate. Modern engineers consulted on the project struggled to craft plausible methods even with advanced cranes, multi-axle transporters, and precise staged lifts. The consensus was clear. Moving blocks of this scale in antiquity is beyond our current understanding and records. This disparity casts doubt on traditional historical narratives surrounding the site's construction methods. Faced with these facts, researchers are left with two unsettling possibilities. Either the builders accessed an unknown technology, lost to history, or the engineering and logistical systems at their disposal far exceeded anything previously attributed to ancient civilizations. Both options force a reconsideration of how we measure human achievement in the distant past. Skeptics caution that some weight estimates may be off, and independent verification remains necessary. Still, the scale problem at Baalbek refuses to relent under scrutiny and breaks the mold of incremental progress models so dominant in archaeology. The overwhelming size and precision of the stones weigh heavily on our understanding of human history. They hint at a forgotten era of advanced skills, sophistication, and perhaps entire cultures lost to time. The stone's presence demands new explanations, not just about engineering, but about the very origins of civilization. As the physical magnitude of the stones sinks in, it becomes impossible to ignore the broader pattern emerging, one that connects Baalbek to an extensive, prehistoric network of engineering knowledge that spans far beyond its walls. A widespread lost engineering tradition. The investigation into Baalbek's mysteries took an unexpected turn when the AI was tasked with comparing its unique engineering patterns to other ancient sites around the world. This step, initially expected to yield minor similarities, instead revealed clusters of shared construction signatures spanning vast and culturally distinct regions. The findings suggested a complex network of prehistoric knowledge rather than isolated achievements, hinting at a broader tradition of advanced engineering lost to history. Microscopic examinations of tool marks on Baalbek's stones showed remarkable parallels to samples from sites like Göbekli Tepe in Anatolia, Nabta Playa in the Egyptian desert, early layers of Jericho, Maltese temples, several Caucasus dolmens, and pre-dynastic foundations in Egypt. The consistent angles, depths, and shapes of these marks defied coincidence, implying a common methodology or shared ancestral knowledge across time and geography. Astronomical alignments added yet another layer of connection. Several of these disparate sites aligned precisely with solstice or horizon events dating back to prehistoric eras, long before the rise of recorded civilizations. These solar orientations matched cycles far older than classical Egyptian or Roman astronomy, indicating sophisticated sky observations with a deep temporal reach. Geological patterns reinforced the link. Baalbek's builders had meticulously placed each stone on the strongest bedrock patches, avoiding fractured or weak zones by mere feet. The AI showed that this careful subsurface selection was mirrored in other sites, where strong ridges were chosen and fault lines avoided with similar precision. Such coordination points to shared geological expertise embedded in construction traditions. More striking were similarities in quarry signatures. Baalbek's freeze-and-thaw extraction methods resembled fracture patterns identified in sites like Knoblia and some Caucasus quarries. These extraction techniques require a scientific understanding of temperature effects on stone, a knowledge surprisingly consistent across distant locations. The repeat presence of these features challenges notions of isolated invention. When the AI integrated tool marks, astronomical data, geological mapping, and architectural proportions, one conclusion emerged. These ancient sites expressed a single engineering tradition. This tradition likely involved knowledge transfer, shared problem-solving methods, and cultural continuity, reaching far beyond what historical records acknowledge. Communication or trading networks probably connected diverse groups in ways now lost to time. While these interpretations are speculative and invite rigorous external scrutiny, the pattern's strength compelled the team not to dismiss it lightly. Baalbek was no longer an archaeological anomaly, but part of a widespread prehistoric network. This network's presence raises profound questions about vanished civilizations, lost technologies, and knowledge erased from our collective memory. The implications are as unsettling as they are exciting. If advanced geological, astronomical, and engineering skills once flourished across vast regions, and collapsed without trace. It warns us that human achievement is not always a one-way march forward. Entire chapters of history may lie buried 10 feet beneath accepted timelines, waiting to be uncovered. One overlooked dimension is the possibility of standardized training systems that predate formal institutions. The recurring precision across distant sites implies that knowledge may have been transmitted through long-standing apprenticeships or cultural lineages rather than written records. Such systems could preserve complex skills for centuries, even millennia, while leaving little trace once disrupted by environmental collapse, migration, or social upheaval. Equally intriguing is the role of environmental memory. These builders appeared to anticipate long-term geological and climatic changes, selecting locations resilient to erosion, seismic stress, and seasonal extremes. This suggests not just technical skill, but inherited observational knowledge accumulated over many generations, an understanding of landscapes as living systems rather than static backdrops. Finally, the disappearance of this tradition raises difficult questions about historical erasure. Shifts in power, belief systems, or catastrophic events may have severed continuity, leaving later cultures to inherit the structures without the knowledge behind them. What remains are monuments stripped of context, silent survivors of an intellectual world that collapsed, reminding us how easily advanced understanding can vanish from human memory. Another possibility is that this tradition relied heavily on oral transmission and symbolic encoding rather than texts. Knowledge may have been embedded in rituals, spatial layouts, or mythic narratives tied to the sites themselves, making it legible only to initiates. Once those cultural frameworks dissolved, the technical meaning collapsed with them, leaving behind immense structures whose original purpose and methods became indecipherable to later civilizations. There is also the unsettling implication that later civilizations may have deliberately distanced themselves from this inherited knowledge. As societies reorganized around new religions, political systems, or social hierarchies, older engineering traditions could have been dismissed as dangerous, heretical, or irrelevant. Over time, selective preservation may have favored myth over method, ensuring that the physical monuments endured while the intellectual systems that created them faded into obscurity. Baalbek's mysteries take us beyond stone and sky, revealing a lost world of advanced knowledge and engineering far older than we imagined. This challenges everything we thought we knew about ancient civilizations. If you found this journey into the depths of history intriguing, don't forget to like and subscribe for more revelations that rewrite the past.